Welcome back to Robominions.in AI interview preparation app. The topic of this video is counting degree 1 nodes in a binary tree. So this is the code for counting degree 1 nodes in binary tree. Before tracing the code, I would request you to watch this video on a laptop or a bigger screen. If you're watching it on a phone, please make it as a full screen and watch it, and highly recommend you to watch it on a laptop. And after watching the video, I also request you to download the app Robominions.in AI interview preparation app. Using this app, you can revise your concepts by just clicking back and next button. You control the code and you can do your revision. So you get the total control of the code at every stage. You can just click back and next button. Okay. And to download the app, you have to visit the website robominions.in. Click on download latest version. If you have a Windows laptop, then click on download for Windows OS and then click on download anyway. Then you can start using the app. So coming back to the main code, we have counting degree 1 nodes in binary tree. Let's start tracing this code. And don't forget to follow the arrow. The arrow will go to every stage of the code where the execution is happening. Okay. So we have hash include stdio.h, that is included. Then we have hash include stdlib.h. Then we have hash include binary tree create.h header file. So this part of the code will create a default valued binary tree for you. So it has values 10, 11, 12, 13, 14, 15 and 16 inserted to the binary tree and creates a binary tree for you. So this header file code has already been explained in the video DSA41 creating binary tree video. Please watch that video if you have not yet watched. So let's continue with the topic. Then we go to int main and then we go to root. Root equal to, so we are creating a root pointer, root equal to create binary tree. This function is present in the header file binary tree create.h. So that will create a binary tree for you, and the address of the first node is returned to the root. And then we do a count of degree 1 nodes in tree, and we call the function count degree 1 node. So count degree 1 node, and we pass root pointer to that count degree 1 node function. So now we have this node, target node, marked with a blue box. Okay. Now we have count degree 1 node. This node has a hash 100 address that has been received in the iteration pointer. Then we have int left count equal to 0, int right count equal to 0. Then we have iteration itr not equal to null. So this node is not equal to null. It is a valid node. It is true. Then left count equal to count degree 1 node of iteration left. So you can see here for left count equal to count degree 1 node itr of left. So itr was this, itr of left is hash 200. So it has gone to this node. So now we call the count degree 1 node function recursively. So now we have itr, this node itr is not equal to null, true. Now it again moves to the itr of left. So again count degree 1 node itr of left function is called. It has gone to this node now. So again we have recursively called count degree 1 node. Next we go to itr not equal to null. Yeah, even this is a valid node. It is not equal to null. It comes inside the if condition. Now count degree 1 node function is called, and itr left is null for this. So we have a null for this node. So count degree 1 node, left count equal to 0, right count equal to 0, itr not equal to null. Itr is null, null not equal to null is false. It returns 0. So 0 is returned to the left count. So 0 is returned to the left count. For this node, left count is 0 now. Then it goes to the right count equal to degree 1 node of iteration right. So itr right is null. So it goes to the degree 1 node. itr of right now has received null. So left count equal to 0, right count equal to 0. ITR not equal to null. ITR is null, right? So null not equal to null is false. It returns 0. So both left count is 0, right count is 0. So right count is also 0. Then if we have ITR left not equal to null, it is equal to null, 0, and ITR right not equal to null, that is also 0. So 0 XOR 0 is a 0, that is false. So it goes to the else part, and left count plus right count is added, and left count is 0 because it doesn't have any left child, it doesn't have any right child, so both is 0. So 0 is returned back to this node. So 0 is returned back to that node, and left count now is 0 for this node because there is no single degree, there is no degree 1 node available in the left side of this node. So as this is marked red. Now for this node we go to the right side, so it goes to the right side. You can see right count equal to degree 1 node ITR of right. ITR, this is the ITR, its right is #500. We have gone here now. So now we call the degree 1 node function again. Left count equal to 0, right count equal to 0. ITR not equal to null. This ITR is a valid node. It is not equal to null. It is true. It goes inside. Now it calls the left count equal to degree 1 node of ITR of left. So now ITR is this node. ITR of left is null. So null is passed to this, passed here. So now we have degree 1 node, left count, right count. Now ITR is null, right? So because here you have left child as null. Null not equal to null is false. Comes out, returns 0. Returns 0 for left count. So left count equal to 0. Then it goes to right count. We have count degree 1 node, ITR of right. So ITR of right is null here. So again count degree 1 node. Now ITR of right is null. Goes to left count equal to 0, right count equal to 0. ITR not equal to null. So ITR is equal to null here. So that becomes false. Then it returns 0. So 0 is returned to the right count. So left count is 0, right count is 0. Now it goes to the if condition. In the if condition, ITR left. So in the if condition we have ITR left not equal to null. It is equal to null, that is 0. XOR ITR right not equal to null, that is also 0. 0 XOR 0 is a 0, it is false. So it goes to the else part, and you return left count plus right count 0 plus 0 as return 0 to this node. Now right count equal to 0. Then we have if iteration left is not equal to null is true. Iteration right not equal to null is true. But 1 XOR 1 is 0. So that is why this condition becomes false. It goes to the else part. So in the else part we have left count 0, right count 0, because there are no any 1 degree nodes in the left side or right side. So both the count is 0. So it returns 0. So this will return 0 for the root node. So it will return 0. So left count, even this is turned red. So so there are no degree 1 nodes in the left side of this root node. Then we go to the right side. So we go ITR right. So ITR right, we have gone to this node. So now we have ITR right. So ITR not equal to null for this node, it is true. It is not equal to null. So now this nodes we go to left side. So we have, you see, we went to left side. Because we have ITR of left. We call that on the count degree 1 node. We send the left node address. We sent that left count equal to 0, right count equal to 0. ITR not equal to null. This node is not equal to null. It's true. It's a valid node. It goes inside the if condition. Now again we call the count degree 1 node ITR left. ITR left of this node is null. You can see here it is null. So it is not it passes null here to the function. The function is called again ITR left. So left count equal to 0, right count equal to 0. Now ITR is null, null not equal to null is false. So it comes out, it doesn't go inside the if condition, it returns 0. So 0 is returned for left count. So 0 is returned for left count. Now for right count, we have ITR right. ITR right is null. So count degree 1 node, ITR right is null. So that is passed. Then we have left count equal to 0, right count equal to 0, ITR not equal to null. Since ITR is null, null not equal to null is false. So it doesn't go inside the if condition. We have again return 0. Return 0 for this node. So right count equal to 0. Then we go to the if condition. In the if condition, we have so this is the ITR, right? ITR left not equal to null is false, 0. ITR right not equal to null is also, because both are null, left and right child are null for this node, ITR, okay, this node. Not equal to null is also false or 0. 0 XOR, this operation is XOR. 0 XOR 0 is 0 or false. So it goes to the else part and it returns left count 0 plus right count 0, because both are 0. It returns back to this node. So left count, this will turn, this box will turn red now. So you can see it has turned red and it has gone, the control has gone back to this node now. So now we go to the right side of this node. So you can see we have gone to the right side because we have ITR right. So iteration right. So we have gone to this side. Now we again pass hash 700 for count degree 1 node. We have passed hash 700. Goes inside left count, right count equal to 0. Sorry, goes initializes left count equal to 0, right count equal to 0. If ITR not equal to null, this node is not equal to null is true. It goes inside the if condition. Now it calls again count degree 1 node, ITR left. ITR left is null for this node. You can see ITR left is null. So null is passed for count degree 1 node. So null is passed to count degree 1 node. So here condition null not equal to null is false. So it returns, it goes to return 0. Return 0. Now left count for this node is 0. Now it goes to the right side. Right child is also null. ITR right is null. So null is sent here there. Then it comes down. Null not equal to null is false. Again that also returns 0. So both left count and right count of this node is also 0, 0. So it comes to the if condition. Now in the if condition for this node we have ITR left null, null not equal to null false, ITR right null not equal to null false. So 0 XOR 0 is 0 or false. So it comes to the else part. Here it returns left count because we have already calculated the left count, there is nothing. So 0, right count 0. So that is returned back to this node as a right count. So you see it has returned, it is turned red and it has been, the control is returned here. Now when I do next, now it comes to the if condition. The recursive call has ended and come back. So now it is back in this node. Here we have ITR left not equal to null. There is a left child, there is a right child. 1 XOR 1 is 0 or false in XOR case. I hope you remember the XOR table. 0 1 is 1, 1 0 is 1, 0 0 is 0, 1 1 is 0. So that is XOR. So it comes to the else part. Here it returns count. So count for this node is 0 and 0 because there are no 1 degree nodes in the child or in any of the child. So even this box will turn red because even this box is a degree 2 node, degree 2 node, right? It is not degree 1. So it will return. So now it has returned the count back to this node. So for this node, left count is also 0, right count is also 0. Now it comes to the if condition of this recursive function. So the which had the root, right? So there it comes. Now this node is there. So recursively, so both the recursions have ended. So now it comes to the if condition. Here again you can see there is left child, there is right child. So 1 or 1 is 0 or false. Comes to the else part, it counts the left count and right count, 0 plus 0. Even this is not a degree 1 node. So it returns. So you can see count of degree 1 nodes in the tree is 0. So there are no degree 1 nodes in this tree. All are red. Red indicates there are no degree 1 node in this tree. Okay. And then it comes out of the main function. The time complexity, as it is iterating through each of the nodes, it's order of n. Okay. And if you want to access the code, please click on the code button here in the app, download the app and click on the code button. You get the access to the code and you can trace the code step by step using this app with the back and next button. So before going to exam or before going to an interview, if you want to revise all these complex topics, you just need to click back and next button and you can understand. You have already watched the video now. So it all needs a revision, and this can be revised by clicking back and next button in a span of 3-4 minutes. So you get the entire picture of how you are counting degree 1 nodes, counting degree 2 nodes. For GATE exam, this will be really helpful. Okay, so download the app robominions.in AI interview preparation app. Okay, thank you guys. See you soon. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.